Okay, so this question says this is a scale plan of a rectangular floor. Now, because they said scale plan and they're telling us what the scale is, it means this is accurate. And they've given us a clue here as well. So obviously keep watching out for key ideas in questions. And so that means we can use a ruler to work out the actual dimensions. So we get our ruler and we measure as accurately as we can, making sure we line 0 up at one end of the line. And we can see that this is 11.9 centimetres. 11.9 centimetres. I suspect because of the photocopying it was probably going to be 12. I'm going to use 12 because it's near enough 12. Okay, so if 1 centimetre represents 2 metres, then 12 centimetres is going to be 24 metres. Okay, and the width for this is 4 centimetres. So this is going to be 4 centimetres, which in real life is going to be 8 metres. Again, the scale, every centimetre represents 2 metres. So 12 times 2 is 24 metres, and 4 times 2 is 8 metres. So we've worked out the actual dimensions of the floor. That will give us at least 1 mark for method. She's going to cover the floor with boards, and each board is rectangular, and each board is 1.2 metres long and 1 metre wide. Okay, so 1.2 metres long, well, and 1 metre wide. Now, when you're doing these kind of questions, my suggested technique is to imagine what goes on in real life. So we're fitting these boards, they're 1.2 metres long, and they're 1 metre wide. So now I've laid them out this way because I can see straight away that it's 1.2, thinking that that's 12, 24, there's obviously a connection going on there. So I can see quite quickly that the number of boards I'm going to fit along here, I can do the calculation 24 divide by 1.2, which is 20. Okay, 24 divided by 12 is 2. But because I'm dividing by 1.2, I'm dividing by something that's 10 times smaller, so I'll end up with an answer 10 times bigger. So 20 boards along the length. Now again, the boards were 1 metre wide, and I can see that this was 8 metres. So in this direction, I'm going to get 8 board widths. Because 8 divided by 1 is 8. So the number of boards needed is going to be 20 times 8. So that's going to be 160 boards. Okay, so Mrs. Bridge has 150 boards. Does she have enough boards? We will show you your answer. Okay, so does she have enough boards? So the answer to that is not enough boards, as she needs 160 boards. Okay, so that's a classic way of doing the kind of floor problems, tiling problems, wall problems, fitting problems, painting problems. Just think about what goes on in reality. How does it work? Well, we're fitting these boards along this length, so every 1.2 metres, how many of those go into the width there? 24 divided by that just gives us 20 boards along the length and so forth. You can do it by area. So we could have said that just to show an alternative method. So we could have done it by area. So the alternative would be to say, right, the area of the floor is equal to 24 times 8. 28 is 160, 4 8s are 32, so 192 square metres. The area of a board is equal to 1.2 times 1, which is 1.2 square metres. Therefore, the number of boards would equal 192 divided by 1.2. Well, that's the same as saying 1920 divided by 12. So we'd get our long division method sorted. So 12s into 1 doesn't go, so we push the 1 over. So 12s into 19 is 1, remainder 7. 12s into 72 is 6, 6 12s is 72, no remainder. 12s into 0 is 0. So we'd have ended up with 160 boards, this method as well. The only problem with the area method is if the numbers don't go in nice along the edges, then you're going to have the need for pieces over, bits over, and you've got to be careful you don't miss that. So try the fitting method is usually the best way of doing those kind of problems when they're fitting things into shapes. But the area method quite often works as well to give you an idea of what's going on, and if they fit exactly, then it'll give you the same answer exactly. Okay, so that's a fitting problem.